All right, let's talk about a truly wild idea. Something that sounds like it came straight out of a Saturday morning cartoon. But today, we're going to give it a serious look. What would actually happen if we tried to plug a volcano with concrete?
I mean, think about it for a second. History is just littered with, let's say, ambitious engineering projects that went south. But what if you were looking for the absolute worst one? The idea that just completely spits in the face of physics. Where would you even begin?
Well, you might just land on this. This is our candidate for the heavyweight champion of bad ideas. And look, I get it. At first glance, there's a kind of simple brute force logic to it, right? But as we're about to find out, this plan isn't just a bad idea, it's a recipe for a geological scale catastrophe.
So let's dive into it. Section 1, a ridiculous proposition. We're going to take this completely absurd idea and treat it with some serious scientific curiosity. We'll use real volcanology to see exactly where and how spectacularly this whole thing would blow up in our faces, literally.
You know, the thinking here is basically plumbing 101. You see a leak? You patch the hole. Makes sense. But here's the thing. A volcano is not a leaky faucet in your basement. Not even close. It's the planet's pressure release valve. And thinking of it as just a simple hole, well, that's mistake number one. And trust me, it's a big one.
Which brings us neatly to Section 2, inside the pressure cooker. Because to really grasp why this concrete plan is so spectacularly awful, you have to understand what's actually happening deep, deep underground.
So deep beneath the volcano, you've got this thing called a magma chamber. Think of it as the volcano's engine room. But it's not just a big cave full of molten rock. The really important part here is the gas. It's packed with dissolved gases, all under insane pressure. The best analogy, it's like a planet-sized bottle of champagne that's been shaken for 1,000 years, just waiting for that cork to pop.
And hey, if the champagne bottle's too fancy, just think about a simple can of soda. We've all done this, right? You shake it up, and you know instinctively, do not open that yet. A volcano works on the exact same principle, just, scaled up a lot. The Earth's crust is the aluminum can, the gassy magma is the soda, and that volcanic vent, that's the tab you really, really don't want to pull.
So here's where our concrete plug comes in. And it is the fatal flaw in the plan. Go back to that shaken soda can. If you try to hold the tab down with your thumb, does the pressure just magically disappear? No way. It builds and it builds, looking for any weak spot it can find. That's exactly what happens here. By plugging the vent, we're not solving the problem. We are actively turning a regular eruption into a planet-sized bomb.
Okay, let's move on to Section 3, the concrete catastrophe. So let's just pretend for a minute. Let's say we ignore all the geologists who are screaming at us to stop, and we actually go through with this thing. How does this play out, step by step?
I mean, first off, the logistics alone are just staggering. We are talking about billions of tons of concrete. Then you have to haul it all up the side of an active volcano. But okay, let's say by some miracle we pull it off. We pour this massive plug. And then what? We just wait? The plan seems to be that the immense geological forces of the Earth will just shrug and go home. Spoiler alert, they won't.
And the consequences would start almost immediately. The pressure, with nowhere to go, starts pushing outwards on the mountain itself. The ground would literally start to bulge up, like a balloon being overinflated. Then, those trapped gases start punching new holes right through the rock, blasting out the sides. Our plug isn't containing anything. It's just making the volcano angrier and angrier. And then, it's over. Failure. That plug, no matter how thick or how strong we think it is, stands zero chance against the focused power of an entire magma chamber. It doesn't just crack, it shatters. And what follows is not the eruption we were trying to stop, it's something far, far worse.
And that brings us to our final section. Nature always wins. The plan failed spectacularly. So now, what are the consequences of that failure? What did we actually unleash?
What we get is a cataclysm. We're not talking about a little lava flow here. We are talking about a Plinian-style blast, the most violent type there is. Think Mount St. Helens, think Vesuvius. All that pressure we foolishly trapped gets released in one catastrophic moment. And our concrete plug, it's now billions of tons of superheated shrapnel, making an already terrible situation infinitely more destructive.
Let's try to put a number on this, just to wrap our heads around the scale. The energy released would be over 10,000 times greater than a normal eruption. We are talking about an explosive force rivaling hundreds of atomic bombs going off at once. We didn't stop the volcano, we armed it.
So what's the lesson here? What's the point of this whole crazy thought experiment? It's actually pretty simple. Humility. We cannot put a cork in the Earth. These are forces that operate on a scale that just dwarfs anything we can build. The only sensible path forward isn't to fight them, but to study them, respect them, and learn to predict what they're going to do.
And that leaves us with one final question. This absurd hypothetical, it forces us to confront the raw power of our planet. So, if containment is totally impossible, the real question becomes, how can we get better at understanding these forces to predict eruptions, save lives, and maybe even harness some of that incredible geothermal energy? The goal isn't to control the planet, but simply to learn how to live with it.